Hello, mathletes. We are beginning a new lesson today, and our new lesson is going to be covering our learning target, and the learning target for today is I can solve math problems with operations in scientific notation by doing adding, subtracting, multiplying, or dividing. So today we're talking about lesson 2.4 and operations in scientific notation. So if we look at this example down here, the table shows the 3 largest countries' population in North America. So in North America, and this goes back to 2011, this data, so it's not quite as accurate today being in 2020, but finding the total population. So if we want to find the total population of these 3 countries, what operation are we going to do? Add, subtract, multiply, or divide. So total population, total means that we are going to add these 3 numbers together. Okay, so we're going to add these 3 numbers together, the United States, Canada, and Mexico. Well, there's a couple different methods we're going to do. So this first method here is going to write each population with the same power of 10. So if we look at the United States, it's 10 to the 8th, Canada is 10 to the 7th, and Mexico is 10 to the 8th. So in order to do that, we're going to do a little bit of review, and then we're going to come back and solve this problem. So what we're going to talk about is scientific notation and if this particular problem is in scientific notation. So first, we have to check, is this first number right here bigger than 1? Yep. Is it less than 10? No, it's not. This is 28, and we need to be less than 10. So that means we are going to have to move the decimal 1 point to the left. So if we move it 1 place to the left, what's happening is this number is going down by a power of 10 or a multiple of 10. So this whole entire thing represents one number, and it's kind of in 2 halves right here. So if this half goes down by a power of 10, this one has to go up by a power of 10. So in order to do that, if this is going to go down, so it becomes 2.842, then we still have times 10. This is going to have to go up. So now this number is in scientific notation, 2.84 times 10 to the 8th. All right, let's try another one. So we have another number. Is this considered scientific notation? Well, again, we start here, and is that number between 1 and 10? And the answer is no, it's not. So we are going to need to move this decimal 1, 2, 3 places so that it becomes 6.2 times 10. Well, if this represents one number, and we kind of cut it in half, if this went up by 3 places, 3 groups of 10, 3 powers of 10, this one has to go down by 3 places, down by 3 groups of 10. So we're going to take 8 and minus 3, so this would be at 10 to the 5th power. So now this number's in scientific notation. This is bigger than 1, less than 10, times 10 to a power. All right, let's just do one more here to make sure we've got that concept. Is this in scientific notation? Again, look at this number. Is that bigger than 1? No. So we have to move the decimal 1, 2 places. So this is getting 2 bigger so that it becomes 3 times 10. Now, how do I adjust this exponent? So this got 2 bigger. This needs to get 2 smaller. Okay, so this is need to get smaller. So think on the number line. If we are at 1, 2, 3, 4, -5, where does this number get smaller? Smaller goes to the left, and we're going to go 2 places, so this would be a -6, and this brings us to a -7. So remember, if you adjust one half of that scientific notation, you have to adjust the other half. So that's where we're at in this problem right here, is that our powers are not the same. So we have a 10, 7, and an 8. So I have to adjust this to make this one bigger, so it's times 10 to the 8th, If this is going to get bigger, that has to get smaller, so it becomes 0.338. Now that they are all powers of 10, what we're going to do right here is add all those multipliers. The multipliers are those numbers in front, the 3.1, the 0.338, and the 1.1. So we're going to add all three of those together, and we get 4.583, and then you keep that power, so you keep the times 10 to the 8th. So they add these all up, and sometimes here they just want you to go one place or two places. So if you wrote it as 4.538 times 10 to the 8th, that would totally be fine. Okay, another way, a second way, is to change all of those numbers into standard notation. So just like we practiced yesterday or the day before, we're going to just take all of those numbers and write them out with all those zeros after it. And then you can add them together, and we'd get this number right here. And then we want to convert that into scientific notation. So go put your decimal between your 4 and your 5, just like we have here, and then count how many places you move that decimal. Well, that's 1, 2, 3, 4, 5, 6, 7, 8 places, and that's why we have 8 as the exponent. So we can either do it the first way, where you make them all the same exponents and then add their multipliers here. This word's going to show up on one of your assignments later, a multiplier, and then you keep the power and base. All right, let's try another one here. So it looks like we are adding and adding. Okay, so we have a 6, a 5, and a 6. So this needs to get one bigger, and because this is getting bigger, this has to get smaller. And it only got bigger by 1, so this is going to get smaller by 1, and smaller is going to go to the left. So now we are going to add the multipliers. So add 4.2, 0.225, and 2.8. So grab your calculator and add those numbers together, and let's see what we get. So 4.2 plus 0.225 plus 2.8, and I get the number 7.225, and then keep your base and power. Keep the times 10 to the 6th. All right, let's go on to the next screen. And this one actually just is the same problem we just did, so I'm just going to go to number 2. So in here it looks like we are subtracting, so we need to do the same thing. The powers all need to be the same. So we have the third, and the second. So that one's got to change. This one has to go up to the 3. So if this is going up to 3, so we're going up by 1, this has to go down by 1. So we're going to move that decimal down, so it becomes 0.1. Then we're going to take 8.5 minus 5.3 minus 0.1. So that's taking all those multipliers and subtracting them. And if you grab your calculator and do that, we get a 3.1, and then we keep it times 10 to the 3rd. All right, going on to number 3, what do we have? A 2, a 2, and a 2. Oh, they're all 2s. So we can write times 10 to the 2nd, because they're all the same, and then add 1.25, 0.5, and 3.25, and I think that comes out to be exactly 5. All right, number 4, give it a try. See if you can do it on your own, and then come back and listen to the video to finish her up. All right, so we have a power of 5, a power of 4, and a power of 2. Okay, so we got to get those all the same. So I'm going to make this one go up by 1. So this is going to go down by 1, so it becomes minus 2 minus 0.26. All right, this one, it's got to go up 3. This has to go up 3, so it's going to be times 10 to the 5th, and I have to move this 3 places to get smaller, so it's going to be 0.0019. Okay, I'm going to grab my calculator, and I'm going to do 6.2 minus 0.26 minus 0.0019. And when I do that, I end up with 5.0 9, 3, 8, 1 times 10. And remember, keep that power, and that power is to the 5th. All right, multiplying and dividing are a little bit easier because we don't have to get those powers the same. So we just need to remember our rules from before, that when we multiply, we add exponents. So this is going to be times 10, and if I take 9 plus 12, I get 21. And then if I do 1.8 times 6.7, so do that on your calculator, 1.8 times 6.7, I get 12.06. All right, now, this is the 3 problems we did at the beginning. That's not scientific notation, so I need to write it 1.206, and that number got smaller, so this exponent has to get bigger. All right, one more problem here that we're going to run through, division. So grab your calculator, do 3.46 and divide by 2, so do that on your calculator, and you end up with 1.73 times 10. Now, what did we do? Remember from before with our rules with exponents. If they're as division, we're going to subtract them. So 17 minus 9 is 8. So multiplying and dividing, we do not have to get those exponents to be the same like we did with adding and subtracting. Multiplying and dividing, we're going to take these multipliers and do what they say to do. So this says multiply, so multiply your multipliers together, and then you add exponents. Dividing, just go ahead and divide the multipliers, and we subtract exponents. Okay, those are the 2 things that we're going to do. All right, one last little concept is that on a calculator, this stuff looks a little bit different. So they use an E on a calculator, so they can't get the times 10 in there on everything. So these things are going to be written. So this stays exactly the same because in a calculator we can do the 7.25. But a lot of times you will see the calculator then have an E in here and then a -5. Do you see how it's all one level, no exponents, all just straight across? Oh, just like number 13. See how it's 1.2e and then a 16? It's all level, straight across, nothing up, nothing down, all straight across on the same level. So number 11 would be 8, then times 10, they have it as the e, and then that exponent is a -1, all straight across level. So number 13, if they now want to write that, so this is on your calculator, this is what you see on the calculator, how do you write that on your piece of paper as your assignment? And that would be 1.2, and that e represents times 10, and now make sure you get that exponent written up above as a 16. And then number 14 would be 9, and remember that e, this e right here, represents times 10, and then that exponent is a 1, so make sure you put that exponent up there. So e represents times 10, because they just can't get that leveled out on your calculator. All right, hope this helps, and good luck with your homework assignment for today.